So, two lines in a plane are parallel if they are, fill in the word for you, equidistant. So what does equidistant mean? Well, equa means equal, distant means length between each other, so they have to be equal length between each other the whole way. This means the distance between two lines measured along a perpendicular line are always the same. So meaning, if you have two parallel lines, let's say two parallel lines, you can see my pen right between it, right? Okay? That the whole way along this distance between my fingers will be the exact same the whole way along, right? The whole way along, it's going to be equal, okay? And so it says right here, one of our points is, it says the distance between two parallel lines is perpendicular distance between them at any 2 points. So we just find any 2 points along the two line and find their perpendicular, their distance between the two from a perpendicular line, okay? So here's another theorem. Theorem 3.9 says, in a plane, if two lines are equidistant from a third line, then the two lines are parallel to each other. So basically it's saying if you have two lines that we know for sure are equal distances from some third line, right, boom, then the two sets are also parallel, okay? Now, find the distance between parallel lines L and M with these equations. Y equals 2x plus 1 and y equals 2x minus 3, respectively. So let's start by graphing, okay? Well, the first one, this is line L, okay? So it starts at 1 and goes up 2 over 1, up 2 over 1, up 2 over 1, or down 2, back 1, okay? And then we just play connect the dots, okay? Well, assume that my line's really good. It goes along those. Now, let's go to the next one. Okay, actually, real quick, that is line L, right? Here's line M. So it starts at -3, goes up 2 over 1, up 2 over 1. Oops. Yeah, actually it is. Okay, and then we see that we have this line right here. Ooh. Okay, well, again, assume that that is actually parallel. So what it means is, what we're going to do is we're going to find the distance between those two. It's a consistent distance the whole way. Well, assuming my lines are straight, consistent distance between each two. And so what we're going to do is we're going to basically find the equation of a line that is perpendicular. So what I'm going to do is I'm actually going to take this line right here. Now, why do I pick that line? Okay, well, I picked that line because I see it crosses at 1, and it's going to have a perpendicular slope to both lines, and they both have a slope of 2, right? L and M both have a slope of 2, so my perpendicular line is going to be opposite, so negative, and reciprocal, 2 over 1 flipped it, is 1/2, okay? And our B, our y-intercept, is positive 1. So our new line, our blue line, is going to be negative 2x plus 1. There it is right there. So we know that it crosses the purple line and the blue line cross at the point 0, 1. Okay, so that's important. 0, 1, they have the same y-intercept. But we don't know where M and this line, this new line, the blue line, meet on line M. So just like the last problem, what we're going to do is we're going to set the two equations equal to each other and solve for the point of intersection. Okay, now we can kind of guess if we look right there, it's going to be somewhere around 1, -1, something kind of like that, 1, -1, or whatever, okay? So we're going to set those two equations equal to each other, right? The two equations of lines. And so we'll say, okay, so our new line, our blue line, is -1/2 x plus 1, and our line M is 2x minus 3, right? So it's a moron problem. Okay, so I'm going to add 1/2 x, add 1/2 x, okay, and I get 1 equals 2.5x, I'll just use decimals if that's okay, minus 3. Okay, I add 3, and I find that 4 equals 2.5x, divide by 2.5, divide by 2.5, and I find that x, this point right here, x is going to be, I'll go to my calculator, 4 divided by 2.5 is 1.6. Okay? Oop. Now, if I know that x is 1.6, I need to figure out what y is, right? So I can put it into either one, m or our other equation. We can put in the value of 1.6. I'll just put it into m. So I'm going to do, so remember in line m, I'm going to do 2, I guess I shouldn't do equal, okay? 2 times 1.6 minus 3. And so 2 times 1.6 minus 3 is 0.2. Okay, so that kind of looks like, sort of looks like what the point is that we have graphed. But that's our purple point right there. Okay, so think about it. Now we found 2 points on that blue line that are supposedly equidistant apart that are both on the blue point 0, 1 is on our blue line and L, and our purple point 1.602 is on the blue line and M. So we're going to find the distance between those two lines by finding the distance between those 2 points. Okay? So again, distance formula, in case we've forgotten, is x2 minus x1 squared plus y2 minus y1 squared. Okay, and so for our point, okay, let's call this x1 and y1 and x2 and y2. All right, so let's plug in our numbers, right? And so we're going to do x2 is 1.6 minus 0 squared. And then we're going to get 0.2 minus 1 squared. All right, simplified a little bit further. So this is going to be 1.6 squared. And this is going to be negative 0.8 squared. All right, 1.6 times 1.6 is 2.56. Negative 0.8 times 0.8 is 0.64. And so when I add those two together, I get all of this equal to, actually, you know what? I will just scroll down a little bit. It's equal to the square root of 3.2, which is approximately, let's see, approximately 1.8. Okay? So, if we look back, does it look like the distance right here? I'm going to draw that in yellow right there. Does that distance look like it's 1.8 units? Sure, we can say it looks like it's 1.8 units. And that will be consistent throughout the entire distance, kind of like railroad tracks. They're always equal. Just like if you have railroad tracks, that railroad tie right between them would always have to be equal. Otherwise, you have an issue. All right? Hope this helps. If you have any more questions, make sure you email me or let me know.